Imagine giving a machine a photograph and asking it to redraw the same picture from scratch. No instructions, no labels, just, here, understand this, and rebuild it. That's what autoencoders do. They compress the world, then recreate it. Welcome to Clythera Vox. Today, we explore autoencoders, one of the most surprising ideas in modern AI. They sit quietly behind the scenes, powering denoising, anomaly detection, image compression, recommendation systems, and even the foundations of some generative AI you use daily. And the crazy part? They learn without supervision. They teach themselves. What are autoencoders really? At their core, autoencoders are neural networks that learn to copy their input. But there's a twist. They don't copy directly. They compress the data into a small, dense code, then decompress it back. Loss function measures how close the reconstruction is to the original. It's like challenging yourself to describe a movie using only 5 words, and then someone else must recreate the entire movie from your description. It forces the system to learn what truly matters. A simple intuition, the passport photo machine. Imagine a passport photo booth. You step in, the machine takes your picture, then compresses it, removing noise and unnecessary details. Later, it expands that compressed code back into a crisp photo. It doesn't memorize your picture. It learns how to rebuild a face from the essence of one. Autoencoders do exactly this with digital data. That tiny, compressed bottleneck forces the network to focus on important features: edges, shapes, patterns, color structures, object outlines. That's why autoencoders are widely used for denoising images, data compression, anomaly detection, dimensionality reduction, pre-training deep networks. Technical breakdown, approachable deep dive. Architecture. An autoencoder has 3 main parts. Encoder turns the input into a smaller vector, often uses convolution layers for images, extracts features progressively. Latent space, the compressed representation, may be as small as 32 numbers representing an entire image. Ideally, it contains the essence of the data. Decoder attempts to rebuild the original, mirrors the encoder structure, learns how to generate from the latent space. The learning process. The network tries to minimize the reconstruction loss. Common choices: MSE, mean squared error, binary cross entropy. The network updates itself to reduce this gap. If the encoder throws away too much, the decoder fails. If it keeps everything, the model memorizes. The magic is in the balance. Real-world applications. Image denoising. Feed a noisy image in. The autoencoder cleans it automatically. This is used in smartphone camera enhancement, medical imaging correction, noise reduction in low-light photos. Example: take a grainy night photo. The autoencoder reconstructs the scene with clarity. Anomaly detection. Autoencoders learn what normal looks like. When something deviates, they struggle to reconstruct it. This makes them ideal for credit card fraud detection, manufacturing defect detection, intrusion detection in cybersecurity, medical anomaly detection. If the reconstruction error is high, something unusual is happening. Dimensionality reduction, better than PCA. Autoencoders compress high-dimensional data down to essentials. 784-dimensional MNIST image compressed to 32 numbers. Dense customer data, compressed into clusters. Audio signals, encoded into manageable latent features. This is how recommendation systems find patterns. Pre-training deep networks. Before large labeled datasets became common, autoencoders were used to pre-train deep layers. Even today, variants like denoising autoencoders and sparse autoencoders help initialize models efficiently. Variational autoencoders, VAE, a gentle introduction. A variational autoencoder doesn't just compress, it learns a probability distribution of the data. Instead of mapping every image to a single point in latent space, VAEs map them to a region. This allows VAEs to generate new faces, interpolate between images, modify features like smile, lighting, style, create synthetic data. This is one of the earliest forms of generative AI. The future of autoencoders. Though diffusion models and transformers dominate today, autoencoders remain foundational, lightweight, explainable, incredibly useful. They continue powering compression, medical imaging, anomaly detection, and generative systems. Understanding autoencoders gives you a deeper intuition for how machines perceive, compress, and recreate our world.